All right, so first I want to start off with going over question number 1. So let's take a look. I've got 5 to the 4th times 5 to the 3rd. So because I have like bases here, I'm going to keep the base of 5 and add these exponents. So 4 plus 3, that's just 7. And my answer choice is 2. Okay? If I look at question number 2, I have the product. Product, a very important word here. Okay, product means we have to, what is it? Multiply. Yes, very good. Okay, so product means multiply. Okay, so I'm multiplying 1 over 3 x to the 3rd times 1 over 4 x to the 6th. Okay. Well, I'm going to multiply my coefficients. Might as well just do that first. So I've got 1 over 3. Oh, maybe that's a little bit hard to read. Let's undo that. We've got 1 over 3 and 1 over 4. So we're multiplying those. All right, so I'm going to end up with 1 over 12. Now, because I have x to the 3rd and x to the 6th being multiplied, all I'm going to do is keep the base and add the exponents. And that's it. That's all you're doing. All right, I want to take a look at question number 4. I'm going to skip around. Okay, so question number 4, typically some of us get confused by this. We think that we have to double distribute. We are not double distributing here, okay? Because I have a regular monomial being multiplied by another monomial, there is no need for a double distribution. We would only distribute if we're multiplying two binomials. Okay, so there needs to be some kind of addition or subtraction in between a binomial in order for us to double distribute. Okay, so let's give this a go. I've got negative 2x squared times y, all multiplied by 4xy cubed. I'm going to multiply the coefficients first. Sorry about that. We're going to multiply the coefficients first. Let's see. Okay, I'm going to do negative 2 and positive 4. I'm going to get negative 8. Then I have x squared with x. And be careful here. There's that that invisible 1 right there. You have x cubed. Then I have y, technically to the first, times y cubed. And I end up with y to the 4th. So my answer ends up being answer choice 4. All right, very quickly, number 5 should be like nice and quick for us to answer. Okay, for number 5, if I have x to the 0, okay, so if I have x to the 0, well, what's anything to the 0? 1. It's 1, not 0. Be careful. Be careful. All right, I want to flip it over to the next page. So if we take a look at number 7, this one's a little tricky. Okay, this one was on a Regents. I have 3y to the a, all raised to the 3rd, equals 27y to the 24th. All right, so I'm going to raise my coefficient to the 3rd power. Okay, I'm going to raise my coefficient to the 3rd power, and I'm going to multiply the exponents. Okay, so we have power to power rule here. I'm going to raise the coefficient to the 3rd power, and then I'm going to multiply the exponents. Now, because I'm being told that these two things are equivalent, they're equal to each other, well, I'm going to simplify here. I know 3 to the 3rd, that's just 27. And I'm going to leave the y to the 3a equals 27y to the 24th. All right, well, this question's a little different, and it's unlike a problem we've done in class, but you definitely have the tools necessary in order to answer this. So right now, this is what I'm left with. I have 27y to the 3a equals 27y to the 24. Well, if these two things are equal to each other, what's the only possible answer I could have for A? If these two things are equal, right? So I have 27 maps up with the 27. Y and Y. Then I have 3A and 24. Well, somehow I've got to manipulate that A so that way these two things are the same. That way I have 3A and 24 to be the same thing. Well, if these two things are equivalent, I'm just going to set them equal. And then solve for A. And this question comes straight from a Regents, guys. Answer choice 3. All right. Let's see. Let's take a look at question number 8. Question number 8. All right. Well, currently we have 2x. Let's see. 2x to the, or sorry, 2y to the x, all being raised to the 5th. All right. And I'm telling you that that is equivalent to 32y to the 10th. And I'm asking you to find the value of what x is. Oh, all right. So, I've got 2y to the x, all raised to the 5th. Oops. All raised to the 5th is equal to 32y to the 10th. Okay. Well, again, we need to use our rules for exponents. I have a coefficient. Okay, the coefficient here is 2, and it's being raised to the 5th power. So I have 2 to the 5th. Y. Now again, I have a power to a power. I multiply my exponents. And then I'm going to leave what I have on the right. Okay, so very similar problem here. All right. Well, 2 to the 5th. That ends up being 32. You can just plug that in the calculator. And then I have y to the 5x equals 32y to the 10th. Well, again, if these two things are equivalent, I have my 32's match up, my y's match up. The only thing I need to match up still is my 5x and my 10. So I'm going to set 5x equal to 10. When I solve for x, I get 2. Okay? And that is answer choice 1. All right, now I want to take a look actually at the bottom question here, number 13. So I want to take a look at number 13 with you all. So for number 13, it asks you to find the quotient of a binomial and a monomial. Okay, what does the word binomial mean? Okay, good. Binomial means 2 terms, and then monomial means 1 term. So right now I have 12x to the 5th y squared plus 4x cubed y, all being divided by 4x cubed y. All right, well, let's do this piece by piece. Okay, I'm going to use the heart method. And I'm going to end up with dividing 12 by 4, I get 3. X to the 5th divided by x to the 3rd, that's x squared. Y to the 2nd divided by y to the 1st, right? Throw in that invisible 1. I end up getting y. And then I have 4x cubed y divided by 4x cubed y. Well, anything divided by itself is just going to be 1. So I'm left with answer choice 2. All right, I want to skip on to the next page. I want to look at question number 15. So if I give you the area, and I tell you the area of a rectangle is 2x squared, 2x squared plus 4x, and I tell you the length is 2x. We need to solve for the width. So in order to solve for the width, well, I'm just going to rewrite and fill in what I know. I have 2x squared plus 4x equals 2x times w. In order for me to get the width by itself, I need to divide both sides by 2x, the whole thing. Then I can complete this with heart method and finish it out. So I've got 2x squared divided by 2x. Well, 2 divided by 2 is 1. And x squared divided by x to the first is just x. Then I have 4x divided by 2x, and I'm left with 2. So my width is equal to x plus 2. If I take a look at number 16, we just have to remember from comes first. Okay, make sure you know that. From comes first. So this I actually don't need to change the order. From already comes first, so I'm just going to leave that. And I'm subtracting that with negative 4x squared plus 20x. Alright, well, I got to distribute the negative. I'm going to bring down everything I already have. And I end up with 4x squared minus 20x when I distribute that negative. Then I'm going to combine like terms. Be careful. You need to go with what you know. Okay, we're going to combine all of the x squareds. So I have 5x squared minus 4x squared is just 1x squared. And then 1x squared plus 4x squared is just 5x squared. Then I have negative 3 and I have negative 20x, and neither of them have anything in common. So I'm just going to bring these down. And I want to write this in standard form. Question doesn't say it, but I want to keep things consistent. Okay, so this should be my final answer here. All right. So far, so good? All right, now I want to check out, let's look at question number 19. Question number 19 is a great one. So I give you the area, or I'm asking you to find the area given the sides. So I'm asking you to find the area of the shaded region. Well, in order for me to find the area of the shaded region, that's everything over here, okay, I'm going to need to find the total area. So I'm going to need to find the total area. I'm going to have to subtract that out from the area that's unshaded, because I can break this up piece by piece. So the area total, well, that's going to be x plus 6 times x plus 8. And that's because area is length times width. So I'm going to be multiplying those. And I'll be subtracting that by 9 times x. So I have 9 times x. So let's do our double distribution for the first one. I have x times x. I get x squared. X times 8 is plus 8x. And 6x is 6x. And then 6 times 8 is 48. Then I'm subtracting that by 9x. Alright, so I'm going to combine my like terms again. I have 8x and 6x. And then I have negative 9x. 8x and 6x is 14x minus 9x. I get 5x. So I'm left with x squared plus 5x plus 48. And that is my answer for the shaded region. All right, so the last problem I do want to look at with you all is question 20. Question 20 is extremely important, and I want to go over this in much detail to make sure we're prepared for tomorrow. So, first things first. Okay. Oops. I have the length of a rectangular garden is represented by the following. Okay, so I have 2x plus 3 and then x plus 1. So I have 2x plus 3 and then x plus 1. And I'm asking you to express the perimeter. We need to be very careful with our reading. Okay, perimeter means the outside. So I want the entire outside length of this garden. So I have 2x plus 3. I have 2x plus 3. I have x plus 1. And I have x plus 1. When you add them all up, you end up with 6x plus 8. The next part says to find the area of the garden and leave it in standard form. Okay, well, area we know is length times width. And I know the length and I know the width. So I'm just going to multiply them. I have 2x plus 3 times x plus 1. And I'm going to double distribute. So I'm left with 2x squared plus 2x plus 3x and then plus 3. When I simplify this, I'm going to combine like terms. I have 2x squared plus 5x plus 3. And that's my area of the garden. Alright, so the next piece that I want to take a look at is that we have a walkway of uniform width. So I have a walkway of uniform width to be added to the garden. Alright, well, here was my garden. I'll draw it outlined in green. And we had 2x plus 3 and x plus 1 as the dimensions. And I'm going to add a uniform walkway around the garden. Okay, well, if it's going to be uniform, then the distance between here to here, we'll call x. From here to here, I'll call x. And then the same thing on the other side. From here to here, we'll call x. And then from here to here, I'm just running out of space here, we'll also call this x. So if I were to look at this length, or sorry, the entire length from here to here, I have my 2x plus 3. I have x. Notice how I have x over here. I can bring that down. And then I also have my x over here, which I can also bring down. It's giving me this side length of 4x plus 3. Now, if I look at the other side, again, here I have from here to here is x plus 1. So I'm going to bring that all the way over on the side. I also have x. I'm going to bring that over. And then I also have x over here, which I'm also going to bring over. So if I add this all up, I have 3x plus 1. So when I find the area of the garden, including the walkway, I'm going to multiply 4x plus 3 and 3x plus 1. So when I multiply these, I have 4x plus 3 and 3x plus 1. When I double distribute, I end up with 12x squared plus 4x plus 9x plus 3. When I combine like terms, I have 12x squared plus 13x plus 3, giving me my final answer for the area of the garden, including the walkway. Okay, and then the last question says, what is the coefficient of the second term? So the coefficient here for the second term would be 13. This is the coefficient, number out front of the variable, and it's of the second term. Okay, that's of the second term. All right, well, I hope you enjoyed this video. Thanks for watching. Bye. See you tomorrow.